Alright, so this is going to be a fairly, hopefully, short video explanation. Probably won't be short, just I'm terrible at explaining things quickly, so bear with me here. So this project, the requirements of it were to, well, let me start at the beginning. This is my very first big actual project in EagleCAD. I learned it not too awful long ago, and I only made a couple little doodads and this and that's for just for practice and such. But this is the first actual project with actual requirements, where I'm going to start with the design, the requirements, design the thing, pick parts, make a BOM, send the board off to get to a board house, actually order parts, assemble the whole thing, yada yada yada. It's going to be an actual physical thing. So excuse me if I have a couple things wrong here and there that maybe I should fix. Anyways, so this project, what is this project? So this is a pneumatics board, a pneumatics controller board for a small, a decently small, maybe the size of couple soda cans together, volume wise at least. But a pneumatics little hull on our robot. This board needs to control 8 little solenoid valves inside of that hull. They're fairly small. They're 0.75 watt, 5 volt solenoid, so decently low current. And that driver needs to be able to communicate with the main computer in a separate hull over a serial line. And generally, that's the goal here. Overall, I mean, I designed the thing to those requirements and I met them, so hopefully it's going to turn out nicely. I haven't gotten the board yet. I haven't had to go through all the silly revisioning things because things actually don't work because I screwed up somewhere along the way. But so far it seems like a success. So I suppose we should just dive into the components and all sorts of fun stuff. So as for the actual controller, what's going to be controlling the pneumatic outputs and what's going to be talking to the computer, sending packets back and forth, is this little Arduino Pro Mini over here to the right. So if we were to just drop in on this, we got fairly straightforward, just a little Arduino schematic thingamajigger. I can't remember the name of it, what they call it, the schematic objects in Eagle, but digressing. At the top, we have this little CTS, VCC, TX, RTS. This is a little. This is the FTDI 6-pin connector on the Arduino Pro Mini. If you are familiar with the SparkFun library, this is where I got it from. But if you're familiar with it, if you're familiar with the board, this isn't actually on there in the SparkFun library. I had to kind of jump in and make a couple little edits to it. On the actual, like when you go to place the objects, when you place the Arduino Pro Mini, it's going to have those 4 pins in it, but they're not actually hooked up to any like pins on the schematic. So I had to add that and hook them up in the library itself, which was a little annoying, but not a big deal. Anyways, so moving on. So it's a fairly run-of-the-mill Arduino. All these little tags. Over here we have all these little tags. They just say that these pins are hooked up to the various solenoid drivers. These are the input signals, or rather output from the Arduino. And they are just pure digital signals, high or low. They're not PWM, nothing fancy, just on or off really. Over on the right we just have a couple little tagged nets set up for the LEDs, which are over here, and that's generally it. It is a 5 volt Arduino Mini Pro. Everything on the board is 5 volts. However, the input power is not. It's 12 volts over here. You can see it tagged. That is 12 volts because the battery on the main robot's 12 volts. So we just, give it battery. Directly tapped off the battery. And then we regulate it on this board. So, that's that. Now, as I just pointed over here, we have our connectors, because these are kind of important too. We have this DB9 connector. May recognize the schematic thingy, but I'm not sure if it's DB9 or DE9, or ordering a DE9 connector. Don't know what the difference is. I could not figure it out for the life of me. No idea what the little middle letter in the D sub connectors, like what that middle letter means, because it can be A, B, C, D, or E. No idea what that refers to. It said something about the connector configuration or something. I can't figure out what the difference is. I've looked at images of DE9 versus DB9. And it's like they look the exact same thing. All the pins, the dimensions don't look any different. I'm not sure. If somebody knows, tell me. But yeah, we are talking over RS-232. If you're familiar with FTDI, you'll know that that's TTL, communication standard. I'll get to that in a moment. But this is an RS-232 serial connection. However, it is not set up like a normal serial like RS-232 connector like you'd see on the back of old desktop computers and such. It is a different layout. Do not attempt to connect this to any computer or anything. You might fry something on this board, or depending on how you've hooked things up, you might fry the computer with 12 volt. I don't know. I haven't actually looked at what it would do. But don't do it. Bad idea. So right below it, we have J2, which is a fairly run-of-the-mill 0.1 inch header, little thingamajigger. It's just a 2x8 pin header row of headers, I suppose. And this is the output to the solenoid. So you just, stick some little female pin connectors on the solenoid, little hookup wires, and you just plug them right into each of these little slots on the back of it. It's labeled on the silk screen so you can read it, and yada yada, all the fancy stuff. So these are on opposite sides of the board. You'll see that on the layout in a moment here. What else? So, oh yeah, I mentioned these earlier real quick. So these are just a couple little status LEDs, like I said, hooked up to the Arduino. Little current limiting resistors, a couple little, a blue, a green and a red. Green, and then that one's the red one, I believe. LED, just for seeing this and that. Don't have an actual plan for it yet. So I mentioned the whole TTL RS-232 thingamajigger earlier. That's what this is over here. So this is the Max 232 chip. And all that does is it converts the TTL. It converts TTL, not the TTL, but TTL into RS-232. Now that doesn't actually, that has nothing to do with really the actual bits that are being sent over. That has to do with the voltage, I believe. Just changes the voltages that are being sent and how it's being read as higher and low. I'm not entirely certain. That's my understanding. It could be wrong though. But yeah, when I say converts from TTL to RS-232, it does both, because you have a TX and RX channel, and obviously when you receive something in RS-232, you're going to have to convert it back to TTL for it to be received. So it does both. I have another board that's going to be put on the robot that'll convert it back right before we hook it up to, I believe it's being hooked up to a USB port. I need to double check that one, but we'll hook it up somehow. Right above that is, I mentioned the whole everything on here runs 5 volts, but we're giving it 12 volts. That's what this is. So VR1, voltage regulator. Fairly, makes sense, right? So that's just fairly, fairly run-of-the-mill. It's a separate PCB switch mode power supply. It's inputs about 12 volts. Unregulated 12 volts. We'll actually be feeding it 14.4, I believe, because we're running giant lipos on the robot. But it outputs 5 volts at 2 amps, so that's more than enough for 8 0.75 watt 5 volt solenoids, which is, I don't feel like doing the math in my head right now, but it's like 0.05. I did it before at some point. It's a really small amount of current to drive those little solenoids. Not a huge load. However, if we do want to drive bigger solenoids later, the driver is mounted. It's mounted to the board with a little 3 pin 0.1 inch header. Really common kind of thing. We can swap it out for another voltage regulator that just has that same pin out really quickly and easily. Not a big deal. Everything should run the same. Either side of that, we have our input and output filtering cap, low pass filtering. So that just helps get rid of noise from the voltage regulator and from other things too, I suppose. But it is, fairly, they're just capacitors. They're 100 microfarad, I believe. That might change depending. They're up in the air. It doesn't matter. They're not critical what value it is. We want them to be 50 volts because there's going to be some, or at least on the input, because of the inductance and just long cables, we might have a spike or something, and maybe it makes a really high voltage. If we fry the little voltage regulator, what that'll do is it'll fry the little FET on there. It'll fry the transistor, and it'll short it. It'll fail short so that everything that's supposed to be 5 volts suddenly is receiving 12, and that's not good. That would probably blow up more things along the way, which would kind of get crazy quickly. So now to the meat of the thing. Now that we dealt with all the stuff on the right, all these little module block thingies. So unfortunately, Eagle doesn't have some sort of like module system thingy where you can like make one thing and duplicate it for if you need 8 of them or whatever. I heard that Altium does that. I've not really looked into it though. Just kind of heard through the grapevine that that's how that Altium's nice like that apparently. That's expensive though. I'm cheap like that. Too cheap for that kind of thing. So each of these, let's just zoom in because they're all the same effectively. Oh, my bad. Got a little sniffle. So these are all the little drivers. So each of these is hooked up to the input from the Arduino is hooked up here. So sol 0 sig. So solenoid 0 signal input. So this will be either high or low. And what this does is it's switching on and off this p-channel MOSFET. Really small. What was it? I think SOT23. I believe it was SOT23. Package p-channel MOSFET, and that is the core of the driver really. That's just pretty much a solid state switch. So it's just switching on and switching off the current to the all the time, I guess. It's switching on and off current to the pneumatic solenoids. So what that does is, it's just connected to 5 volts it's connected between 5 volts and sol 0 plus, which stands for solenoid 0 positive, which goes straight over to the connector output. Solenoids across here, when this switches on, turns on current goes through the solenoid to ground. There's your circuit. Now there's some stuff, let's go over the gate real quick. So gate's fairly simple. It's just a little pull-up resistor and, my bad, a little input resistance, so we don't, kill the Arduino or, make the Arduino do too much work. But, so when we pull it high, when the pin is outputting high, which would be 5 volts in this case, logic high. Everything's 5 volts. So this would be up to 5 volts. It would pull the gate high, and because it's p-channel, when the gate pin is high, the MOSFET will stop conducting or stop passing current. When the signal is low, what it'll do is it will pull the gate down. It'll pull the gate down to ground, and this current limiting resistor will pass a little bit of current across it, raise the voltage a little bit, but this for the most part, because resistor divider will be low. And then, it'll just switch on and off. It's not high frequency or anything. So these are pretty large resistor values for this application, but not a big deal. Now, I mentioned that there's this stuff below here too. So this right here on the left is just fairly straightforward. It's just a really simple little output LED. Got a current limiting resistor there, 120 ohms, same as this LED over here, this one, green LED. And it's the same. We're using the exact same LEDs just to make life, ordering, BOM, everything easier. But yeah, that's just for us being able to see what's turning on and off, because the solenoids are tiny and then they're in a little case. You can't really hear them turning on and off. So this is the next best thing. You can actually see when the output is getting turned on and when the output's getting turned off. D1 over here, D1 is a really simple flyback resistor. So what it does is when you turn on and off the pneumatic solenoid, because it's a coil, it has inductance to it. It is an inductor. When you turn on and off current to it, it'll produce a voltage, really quick voltage spike, which can be bad for things because voltage spikes can break things, like the MOSFETs, for example, maybe. It's a really small coil, so it's not a whole lot, but it's nice to have little, design things properly. So we have a little flyback diode, and that diode, what it does is when that current, that voltage spike occurs, what happens is that it tries to push current backwards, and that's what this little diode is for. This flyback diode, it lets that current flow backwards, but through itself instead of through anything else. So it'll make a little loop. All that energy that the solenoid is releasing will make a little loop around, because it is hooked up in parallel. Sol 0 plus, ground here, Sol 0 plus. So yeah, it's just hooked up in in parallel with the load. When it makes that voltage spike, does a little spin, and all the excess voltage is dissipated, all the excess energy is dissipated through that diode. It's a little bit easier to see on the actual board, so we'll hop to that in just a second. But that's about it for the schematic. A lot of this will make a little bit more sense on the board because you can kind of visualize things better. It's the whole point of the board layout. But yeah, so I will do kind of a, not quite part 2, but kind of part 2 on the board itself. This is longer than it should have been, but do what you got to do.